As our world becomes increasingly connected, we find ourselves at a critical crossroads. Every byte of data transmitted across the globe carries a hidden cost: energy. Today, as we look toward the horizon of 6G, the conversation is shifting. We are entering the era of green native connectivity. This isn't just about faster speeds, it's about making sustainability the architectural heart of our global infrastructure. It's a leap in responsibility and engineering. The challenge we face is a paradox. How do we support exponential data growth while keeping the network's energy footprint flat, or even reducing it? This question defines the evolution from LTE to the future 6G era. To understand where we're going, we must look at where we began. 4G LTE laid the groundwork for mobile broadband, focusing primarily on raw throughput and basic signaling to manage power during low-traffic periods. In those early days, energy saving was often a secondary optimization, a series of features added on top of a system designed first for capacity. But the scale of our current digital world requires a new approach. 5G introduced ultra-lean design, a breakthrough that minimized always-on signals. By reducing unnecessary transmissions, 5G allowed network components to enter short sleep states during idle moments. This was a critical step in decoupling data traffic from power consumption. It proved that the network could be smarter about when it consumes energy, paving the way for the native sustainability of the next generation. But 6G represents a fundamental paradigm shift. It is the first generation to be designed as green native. Energy efficiency is not an afterthought. It is a core architectural principle from day one. This green native philosophy means every protocol, every algorithm, and every piece of hardware is evaluated for its energy footprint before it ever reaches the network. We are building a system that respects the planet. The performance targets for 6G are staggering. We are aiming for a 10 to 100-fold improvement in energy efficiency compared to 5G, targeting a milestone of 1 terabit per joule. This means delivering massive amounts of data with the energy equivalent of a single picojoule per bit. It's an ambitious goal that requires innovation across the entire technical stack. The focus starts at the base station. Today, roughly 80% of a network's energy is consumed at these sites. To make a global impact, we must start by redesigning how these hubs operate. From power amplifiers to signal processors, every component is being re-engineered. We're looking at the total lifecycle energy, from the moment a node is turned on to the way it handles peak traffic. One of the most powerful levers for efficiency is AI native management. In 6G, artificial intelligence is the brain that orchestrates energy consumption across the entire network mesh in real time. This AI-driven orchestration allows the network to predict traffic patterns with microsecond accuracy, ensuring that every antenna and every server is only as active as it absolutely needs to be. This leads to techniques like micro-DTX. By predicting the exact moment a user session ends, the network can put base stations into a deep sleep for mere milliseconds, multiple times per second. These micro-sleeps add up to massive energy savings without any detectable impact on the user experience. It's the ultimate always-off paradigm, where components are only active when data is flowing. 6G will also utilize extreme massive MIMO arrays. These massive antenna ports are managed by AI to dynamically mute specific elements when they aren't needed to serve a user's location. By muting unused ports and focusing beams with surgical precision, we can reduce base station power consumption by up to 20%. This is spatial adaptation at its most efficient. Beyond software, we're introducing revolutionary hardware like reconfigurable intelligent surfaces, or RIS. These are essentially smart mirrors for the radio environment. RIS panels can reflect, refract, or focus radio waves toward a user. Because they are passive, they can extend coverage into dead zones or around obstacles with nearly zero energy consumption. Traditional repeaters are power-hungry, but a passive RES panel uses only a tiny fraction of energy to steer a beam. This allows us to blanket complex environments in coverage without a massive power draw. This hardware evolution is a cornerstone of the 6G vision. By turning the environment itself into a smart relay, we reduce the burden on active base stations and lower the network's total energy footprint. When energy is focused with surgical precision, waste is eliminated. In legacy networks, much of the broadcast power is lost as it's sent into empty space. 6G changes that. By focusing every joule directly on the user's antenna, we maximize efficiency. It's the difference between a floodlight and a spotlight. Only the intended target receives the energy. Perhaps most transformative is the rise of zero-energy devices. These are the building blocks of a trillion-device Internet of Everything, designed to run without a traditional battery. By eliminating batteries, we solve a massive ecological challenge. These devices are designed to last for decades, harvesting energy from their surroundings to stay connected. They use ambient backscatter technology, piggybacking on existing radio waves from Wi-Fi or cellular networks. They don't generate their own signal, they simply reflect and modulate what's already there. This allows for ultra-low power communication. These sensors can transmit data using the energy equivalent of a whisper, making them ideal for everything from smart agriculture to industrial monitoring. These devices can also harvest energy from light, heat, or the very RF waves they reflect. They are truly self-sustaining, pulling power from the environment to maintain their connection. This shift toward batteryless harvesting devices is a cornerstone of the 6G green native vision. It's a world where technology doesn't just consume energy, it learns to live off the ambient pulse of the world. Integrated Sensing and Communication, or ISAC, turns the network itself into a high-precision radar. The network becomes physically aware of the world it serves. By integrating sensing, the network can see users and obstacles. It no longer needs to waste energy searching for a connection. It already knows exactly where every device is located. This physical awareness enables hyper-efficient, pinpoint beamforming. The base station can track a user moving through a city with a narrow, low-power beam, minimizing interference and power draw. It's a more aware and responsive network. By understanding the physical environment, 6G can optimize every transmission for the lowest possible energy cost, ensuring a high-quality experience for everyone. 6G will also move toward cell-free architectures. In legacy networks, a user is served by a single tower. In 6G, multiple access points cooperate to serve one user seamlessly. This cooperation reduces the need for high-power, long-distance transmissions. By working together, the nodes can maintain a stronger signal with less total power, drastically improving efficiency at the cell edge. However, the path to 6G isn't without hurdles. We face the AI energy paradox. The very intelligence used to optimize the network itself requires significant computational energy. We must balance the energy saved by AI against the energy required to train and run these complex models. This requires new, ultra-efficient AI for green hardware designs. Moving to higher terahertz frequencies also adds complexity. These frequencies offer massive capacity, but they require hardware that is naturally less efficient at current power levels. We're developing new power amplifier architectures to overcome these physical limits. The goal is to make TH's communication as efficient as the lower bands we use today. Then there is the risk of network densification. To meet 6G's capacity goals, we'll need many more small cells. If not managed correctly, the aggregate power of these cells could be massive. This is why the always-off paradigm is so critical. A dense network must be a dormant network, active only in the millisecond a user is present, ensuring efficiency at scale. Global initiatives like HexaX and the ITUR's IMT 2030 vision are leading the charge. They are ensuring that sustainability is baked into the very first 6G standards. This international cooperation is essential. By working together, the global tech community is defining a sustainable future where connectivity and the environment can thrive in harmony. The ultimate goal is the complete decoupling of data growth from energy consumption. We are proving that a faster, more capable network doesn't have to be a more power-hungry one. As we move toward 2030, this decoupling will be the defining metric of our success. It is the technical foundation for a sustainable global digital economy. In 6G, the network will be off by default. This always-off paradigm ensures that components are only active when there is data to transmit, saving vast amounts of energy. This extreme temporal adaptation is what makes the 6G vision possible. It moves us toward a future where every bit of data is delivered with the absolute minimum energy required. We are moving from an era focused purely on spectral efficiency, bits per hertz, to a new focus on energy efficiency, bits per hertz per joule. This is the new standard. This shift in metrics forces us to rethink every design decision. It ensures that 6G is not just a leap in speed, but a leap in our responsibility to the planet and its resources. Sustainability also extends to the physical hardware. 6G promotes eco-design, using recyclable materials and low-power silicon technology to reduce the total life cycle footprint. By designing for a circular economy, we ensure that the network of the future is as sustainable in its physical form as it is in its digital operation. This is the complete 6G vision. Ultimately, 6G is about more than technology. It's about a sustainable future for our planet. A future where connectivity empowers society without harming the environment. We are building a world where the network is as natural and efficient as the ecosystem it serves. This is the promise of the green native 6G era. It's an evolution we can all believe in. The journey from LTE to 6G is a leap in responsibility. It's the evolution toward a truly sustainable digital world that serves everyone, everywhere, for generations to come. By combining AI intelligence, passive surfaces, and batteryless devices, we are creating a network that is green by design, a sustainable infrastructure for the global decade ahead. As we look toward 2030, the vision of a green native network becomes a reality. This is not just a dream, it is the technical blueprint for the future of global connectivity. We are entering a new era of responsibility. An era where our digital progress is measured not just by the speed of our bits, but by the weight of our footprint. 6G is the answer. It is the blueprint for a world where technology and nature can finally exist in balance. A world where every connection is a step toward a cleaner, greener planet. This is the 6G mission. In summary, the transition to 6G involves a total rethink of the protocol stack to prioritize energy saving at every layer. We are witnessing the birth of a green native global infrastructure, a network that will power the innovations of tomorrow while protecting the world of today. This is the technical reality of the 6G prospect. This is the future of sustainable connectivity. This is 6G, green by design, sustainable for life. Join us on the journey toward a greener digital future.